Assalamualaikum. My name is Dania Batrisha, ID 18002463. For lab report control volume, I will present on impact of a jet. For the introduction of the experiment, a torque on the wheel is generated from the impact of the water on the vanes. This causes it to rotate and develop power. Such turbines can generate considerable output at high efficiency. Pelton wheel is best suited to conditions where the available head of water is great and the flow rate is comparatively small. To predict the output of the Pelton wheel and determine its optimum rotational speed, understanding on how the deflection of the jet generates a force on the bucket and how the force is related to the rate of momentum flow in the jet must be done. In this experiment, we measure the force generated by a jet of water striking a flat plate or a hemispherical cup, and will then compare the results with the computed momentum flow rate in the jet. There is two objectives of this experiment. For the methodology, firstly, level the apparatus and set the lever to a balanced position, as indication in tally, with a zero setting jockey weight. The second step is record the weight of the jockey, diameter of the nozzle, height of the vane above the tip of the nozzle at balance lever, and distance from the pivot of the lever to the center of the vane. Then, emit water through the supply valve and increase to maximum flow. Fourth step is to record the collection of water over time interval for the mass flow rate. Then, record at number reducing flow rates for further observations. Then, repeat the steps with the hemispherical cup. This is the setup of the experiment. The apparatus consists of an upward discharging jet, contained within a clear plexiglass cylinder. There are leveling screws on the bottom surface of the apparatus. The weight pan atop the apparatus is attached to the top of a spindle that passes through the lid of the cylinder and down to a flat plate located just above the exit of the water jet. Water is supplied from the lab faucet to the inlet of the apparatus via a hose. Water flowing through the nozzle strikes the flat plate and deflects downward to the base of the clear plexiglass cylinder, where it exits and drains in the sink. For the dimension of apparatus, this is the results of the experiment. Recorded values of quantity collected, measured time, and jockey displacement y are presented in tables shown. For calculations, these are the formulas used. For flat plate, the beta is 90 degrees. The formula used is jet force equals to density of water multiply with flow rate multiply with water velocity by which the jet strikes the vane. For hemispheric cup, the beta is 180 degrees. The formula used is jet force equals to density of water multiplied by flow rate multiplied by the addition of water velocity by which the jet strikes the vane and water velocity after the strike. For the discussion, the graph shows the force produced by a water jet striking a flat plate and a hemispherical cup. It is clear from the figure that the force produced on each vane is proportional to the momentum flow in the jet when it strikes the vane. For the flat plate, the graph slope is 0.97. The inconsistency may be due to systematic experimental errors. Possibility also lies in the behavior of the jet after striking the vane. It forms a radial sheet which impinges on the inner wall of the surrounding cylinder and divides, where some of the water flows down the cylinder wall and some flows outwards. Although visibility is impaired by the spray which is generated, there is some water falls on the top side of the vane. This would cause producing a small momentum force downwards, hence reducing the net upwards force on the vane. For the hemispherical cup, the graph slope is 1.92, so the jet force is 1.92 joules. The maximum possible force is shown to be 2 joules, which occur when the jet is deflected through 180 degrees without loss of energy. The ratio between measured force and the theoretical maximum may seem as efficiency of the vane, which in this case is 0.96. It will always be less than 1.0, as losses will always occur in practice. As conclusion, when there is increase in volumetric rate of flow Q, there is also increase in the force resulted from the impact of the jet on both the flat plate and the hemispherical cup, for the predicted F1 and the measured F2 values of the force. This can be seen clearly from 4 plots accompanied with this report. Prediction of the results is already done from the change in momentum equation of calculating the force. There is discrepancies in the values, where some measured value of the jet force show larger values than the predicted ones. This may occur due to the following reasons. Thank you.